Also, what we talk about will be posted on Canvas for your review. I sure hope as you read this list, none of these things come across as, well, I've never seen that before. That would not be a good sign. All right, you got all 7 things written down? Let's read through them, and then we're going to go about each topic. All right, so number 1, it says midpoint definition. We'll talk about that. Reflection across a y equals x line. We'll talk about that. Rigid and non-rigid transformations. That sounds more difficult than it is. Vectors. Line of reflection between 2 figures. Dilated figure. Rotational symmetry. Corresponding parts of congruent figures are congruent. Okay. Got all 7 things written down? All right, let's go piece by piece. First one, it says midpoint definition. All right, so the definition of midpoint tells us this, that if I have a segment and something bisects it, it bisects it at the midpoint. Now, that bisector could look like this. It could look like this, as long as it hits the midpoint. If it's a perpendicular bisector, that's kind of unique. That means it would be just like this. I'm just freehand drawing it. I could construct it. That means it would be like that, a perpendicular bisector. Okay, so when it talks about the midpoint, then there's some things that we know. Watch this. Let's call this A, this B, and that M. If AB is 8, what is AM? if BM is 3Z, what is AB? No, if BM is 3Z, if that's 3Z, then what is AB? No. I think I heard somebody say it. If that's 3Z, then the whole thing would have to be 6Z. Okay? If AM is x plus 2 and AB, the length of AB is 12, what is x? Okay, let's take a look. If the entire segment is 12, right? And if half the segment is x plus 2, how could we solve it? Well, if the whole thing is 12, what's half of it? So we could set up the equation x plus 2 equals 6, and x equals 4. Okay. You getting the idea of the midpoint? I'd be writing everything down that I'm writing down. It is going to be on video. You can't go back and watch it. Let's move on. Number 2. 2y. All right, it says a reflection across y equals x. All right, what does that look like? All right, that's going to look like this. So if I have a triangle, then it's got to be reflected. Not like that. Reflected across the line. Anybody remember the rule for the reflection of y equals x? Switch to place the x and the y. So if this point was, let's say, 5, 2, then the point of reflection would be 2, 5. If this point was, let's say, 8, 3, then this point would be 3, 8. And if this point was, let's say, 6.5 and 5, then this is 5 and 6.5. Do you remember that rule? You need to remember it. That's how we determine. Now, there's also something else going on. We were going to talk about this later, but I might as well mention it now. If I connect these, you remember that connecting their midpoints is the line of reflection right here? Remember that? Okay, that comes back into play. I don't think we ask you on the test about getting the equation of the line, But that's what we did on the homework and in class. Okay, but flexion across the y-axis. Y equals x. What if this is a double reflection that once we go across this, then we go across here? You remember the rule to cross the y-axis? Anybody? There you go. Try to take the negative of the x, and the y stays the same. Going across the x-axis, take the negative of the y, and the x stays the same. Okay, good so far? We got 2 of the 7 or 8 topics done. Okay, go on. Number 3. Rigid and non-rigid transformations. Okay. The big deal here is non-rigid means that it's a dilation. A rigid means everything else. Okay, so what's a dilation mean? It means when I take a rule like this. Remember when I multiply by a value, if I multiply by 1/2, what happens to it? Does it shrink or get bigger? It shrinks. So like if I have, let's look at a scenario there. Let's say that I have 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. Let's say that I have a rectangle. We'll say that's at 1, 1. That's at 1, 3. This is at 5, 1. And this is at 5, 3. And let's say that we apply a dilation, okay, of 1/2. We cut this in 1/2. How do we do that? Well, we take each point, we go 1, 1, and that becomes 1/2, 1/2. 1, 3 becomes 1/2 and 3/2. 5, 1 becomes 5/2 and 1/2. And 5, 3 becomes 5/2 and 3/2. All right, now let's graph those. 1/2, 1/2 would be way down here. Let's say that it's about right there. One half and 3.5, which is 1/2. So we go 1/2 and that would be right there. 5/2 is 2.5, and then 1/2 would be about right there. And then 5/2 and 3.5 would be about right there. Shrunk it. That is a non-rigid transformation. What's an example of a rigid transformation? Anything else? There's a rigid transformation. If I reflect it, that's a non-rigid transformation. So if I multiply by -1, so negative x and negative y is a non-rigid transformation. Remember, that's also the same as 180-degree rotation. You guys remember this, the rigid and the non-rigid? Good. Move on. Any questions about it? Anything that stirs up in your mind? Anything? Good? Okay. Let's go on. Number 4. Vectors. I think vectors are simple. Vectors is a notation difference like this. Instead of a ordered pair with parentheses, it looks like this. If I have a vector of -3 and +2, if I go from the origin, that means I'm going -3 and +2. There's the vector. If I move a figure like a triangle, -3, +2, if it were up here, I'm supposed to move that figure -3, +2. Means I go -3, +2. -3, +2. -3, +2. There's my new figure. Kind of hard to see. Okay. What if a vector? No, it doesn't get much more difficult than that. I mean, what if it's 5, -4? Well, then it goes 5 over and 4 down. 5 over and 4 down. 5 over and 4 down. Okay? You just don't go off the origin. All right. Any question on vectors? Okay, line of reflection. Okay, this is a big one. Line of reflection. Let's say that I have a graph. Go ahead and make this graph. Oh, sorry, I'm going to have to restart that. I got to reflect it, not just move it. Let me try that. All right. Now, say I've got that picture. How do I determine the line of reflection? Well, if I'm just going to find it, all I would do is connect. Yeah, well, I did this freehand. Connect the points. Yeah, very good. Connect the points and find their midpoint. And then that is the line of reflection. That's not very good freehand, but it's not too bad. These lines would have to be parallel. They should never touch. But you get the idea of the line of reflection, how to find it? You remember that? Okay, it is the midpoint. So this is equal to that. 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 So why did this one not work? Because I didn't reflect it. That was just kind of moved it over and up. That'd be a translation. Right? Rotational symmetry. remember that if we rotate something 180 degrees, the rule for 180 degree rotation is negative x, negative y. So a picture, you know, like the IU symbol, sorry about that. There's the IU symbol. Would that have any rotational symmetry? No. Would it have linear symmetry? Yeah, it would have linear symmetry right here. But no rotational, right? Okay, but if we had, let's say, an X, would that have rotational symmetry? Yeah. And so you can apply the rule if it's on a grid. So let's say that this is at the origin, 0, 0, and this is at negative 2, positive 2. If we rotate it all the way around, then this point down here becomes positive 2, negative 2. Right? You remember us talking about that? Okay. So we've talked about dilation of a figure. We already talked about dilation of a figure, right? When we talked about this, the non-rigid, that's a dilation. It's the exact same. So dilation, 1/2, 1/3, just means you're shrinking it. But you can apply the rule just like we did here for each point for a dilation. Okay. All right, let's talk about, well, the most recent one. This is maybe the simplest one. All right, so corresponding parts of congruent figures are congruent. So if I have, let's say, two triangles that are congruent, okay, then we can name all 6 parts that are congruent. Angle A is congruent to angle D. Angle B is congruent to angle E. Angle C is congruent to angle F. And additionally, AB is congruent to DE. BC is congruent to EF, and AC is congruent to DF. I'm going to mark that in my picture. I mean, angle A would be congruent to D. Angle B would be congruent to angle E. Angle C would be congruent to F. Those are the ones that match up. AB would be the same as DE. BC would be the same as EF. And then AC would be the same as DF. All right. Got it? All right. That's the 7 things you need to know. Open in your book to the last section. Was that page 150? Is that 155? I think it's page 155. All right, if you did not finish, I'm going to give you a few minutes to finish those, I think 9 problems, was it? Yep, 9 problems. Page 155. If you did finish, just hang out. Okay. Before we get out of here, how much time we have? We don't have much time, do we? Oh, okay, yeah. All right, so number 3, let's take a look. It says, does the ray BD bisect angle ABC? Select yes or no. So, D's here in the middle, and it says if ABC is 60, so I'm going to mark this up pretty good, so you got to follow along. So if the whole thing is 60, and the measure of angle ABD is 30, does that mean that D is the bisector? Yes. All right, so ABC is 96, and ABD is 47. Is that half of it? No. That's 94, isn't it? Half of it. Multiply it by 2. And then if ABC is 124 and ABD is 62, is that half of it? Yeah. So I would go yes, no, yes on number 3. Okay, let's go to number 4. It says, is the point C the midpoint of the line? Select yes or no for each statement. If A is 1, 2, B is 3, 4, and C is 2, 3. Is 2 half of 1 and 3? Yeah. Is 3 half of 2 and 4? Yeah. So that would be yes. All right, now let's go -1, 2, 3, -1, and 1, 0. Let's check. Okay, so -1 and 3, what's half of that? That's 1, that works. 2 plus -1 is 1. 1 divided by 2 is 1/2. The 0 doesn't work. So that is a no. Okay, and the last one, we have -3, 0, -1, nope, +5. Oh no, that's B. -1, +5, and C is -2, 2. Alright, let's check. -3 plus -1 is -4 divided by 2. Yeah, that works. 0 plus 5 is 5. 5 divided by 2 is not 2. That does not work. So the answer is no. Yes, no, no. Remember, midpoint formula is x1 plus x2 over 2. y1 plus y2 over 2. That's the midpoint formula. All right, let's go to number 5. It says, is RS a translation of DF? R is 2, 2, and S is 5, 2. Okay, so 2, 2, 5, 2, a translation. 3, 3, that means it went over 1 and down 1. So that means this would have to be, no, up 1. 6, 3. I would say no. So letter A is no. You see how I did that? Looking to see if it's consistent. Okay, so if they have R as -1, 3, and S is 2, -2, all right, what's the change? -1 to +2, that's a 3. 3 to -2, what's that, -5? Okay, so D, -1 to -4, that would work. And then 2 to -3, yeah, that works. -4 to -1, yeah. So I would say the second one works. You see how I'm doing this? Figuring out how they move, make sure it's consistent. Okay. All right. So the last answer for number 5 is, number 4. No, we're in number 5. Sorry, is no. All right, let's go to number 6. All right, we have a square, a trapezoid, and a right triangle. It says, does shape have rotational symmetry? A square does. Does a trapezoid? No, that does not. Does a right triangle? No, that doesn't either. So the only one that I see is a square. Okay, and then number 7, we've got determine whether each image of ABC 1, 3, 2, 3, 4, 5 can be formed with only the given transformation. Select true or false for each statement. Okay. A prime 2, 4. B prime 3, 4. And C prime 5, 6. What do we do? Just add 1? Add 1, add 1. Is that right? Yeah, that looks like that. So, okay, could that be the image formed by a reflection? Oh, can be formed by a translation. Yes, that's true. Okay, so how about -1, 3? -2, 3, and -4, 5. Would this be a negative and keep the same? This looks like this is -xy, doesn't it? Isn't that a reflection across the y-axis? So that's not a rotation, right? That would be a false. Okay, because this right here is representative of a reflection across the y-axis. All right, let's do one more. I think I can squeeze it in there. 1, -5. 2, -3. And 4, -1. Okay, so what about this one? Well, the x's stay the same, and the y's, what in the world happened to the y's? I don't see a pattern, do you? The 3 becomes the -5, the 3 becomes a -3, and the 5 becomes a -1. No. Okay. Here's the answer number 8. True, true, and true. Number 9. What is a specific series of rigid transformations? Well, if you look at that closely, you reflect it across the x-axis and then move it left 5 units. Translate it left 5 units. That's letter A. And then letter B we've done so much, I'm not even going to say it. All right, questions? This is the key. Know how to do those 7 things.